Okay, in this video I want to introduce you once again to chemistry. I know we've already done a couple of activities in chemistry, but I want to make sure we understand the basic idea behind what chemistry is, and then we'll get into some more details as to the organization of matter itself. So obviously here we understand that chemistry is the study of matter and the transformations that it can undergo, and that's the fun part about chemistry are the transformations. Take a look at this. Now this is just neat stuff right here. So as we look at nature, we look at our outside surroundings, we must understand that chemistry pretty much is everywhere. As we look and use chemistry, we can do a lot of fantastic, great things with chemistry. We see in this graphic that chemistry is what we call a central science. It is a part of all sciences: earth science, physics, biology, astronomy. Chemistry is that central science to everything that goes on. In addition, chemistry is a material science. Most of the material items found in this kitchen are devised by some sort of human-created chemical process. So look at this graphic once again. We see a lot of different things that are devised once again by the use of chemistry. 70% of all legislation placed before Congress address science-related questions and issues, a lot of which are about, you guessed it, chemistry. Okay, let's put things in perspective. We have looked at so far things on a macroscopic level. We can see them in our everyday life. We can also look at things in a microscopic level, meaning we could use a microscope to actually see something. They're really, really small. But the world of chemistry is sub-microscopic. We can't see with a microscope. It's below microscopic level. Let's take a look at a grain of sand. In a single grain of sand, we have about 125 million trillion atoms. How much is 125 million trillion? Take a look. Roughly 250,000 dunes of this size, this whole thing is one big sand dune, contain about 125 million trillion grains of sand. And yet, that's how many atoms there are in a single grain of sand. 125 million trillion atoms in a single grain. That's atoms are small, people. They're really, really small. Get the idea? An example of pure substance for matter would be an element. An element, we mentioned before, is a material made of only one kind of atom. So in this example here we have pure gold. So the element gold, we have no other atoms besides gold in this example. That's a pure substance. And the atom itself is the fundamental unit of the element. However, I can also have different things combined together and still have a pure sample. For example, we have sodium chloride here. This crystalline structure of sodium chloride, I have sodium and chlorine bound together. They're chemically combined, and it's a pure sample of sodium chloride. We call these things a compound. So a substance consisting of atoms of different elements would be a compound. These compounds are chemically combined together. They're bonded or attached together. And compounds have properties uniquely different from the elements from which they are made. So sodium by itself, if you ate sodium, you would die. If you ate chlorine gas, you would die. But sodium chloride, that combination, we put it on our food all the time. We eat it all the time. It's great stuff. I love sodium chloride on all my food. So once again, a compound can be a pure sample. So here's water, H2O. It's bonded together. I've got oxygen bonded to hydrogen. So I've got a compound because I have different atoms bound together. So I can have a pure sample of just water. So in this container, this box right here, I have just water, a pure sample of water. Even though I have different elements in there, it's a compound now, and oxygen and hydrogen bonded together has different unique properties than oxygen alone or hydrogen alone. In this situation, we have a physical combination of two or more elements or compounds. So in this container now I have two water molecules. It's a pure sample of water. But if I also throw in this CO2, carbon dioxide, now I have a mixture, a physical combination. Notice that these two molecules are not attached or bound to each other. I've just got a mixture of different things in this sample. So we call this a physical combination. This is a mixture. Mixtures can be of two types. We can have heterogeneous mixtures, which we see here with these rocks, Cupcakes, frosted cupcakes are another good example. Blood is a good example. These are different throughout. The other type of mixture we can have is a homogeneous mixture, which means that it's the same throughout. Homo meaning the same. So we see a solution here of food coloring that's the same throughout the whole container. So matter can have different phases, and we call these states of matter: solid, liquid, and gas, and you're familiar with these from middle school. So looking at these three things, we want to look at how we go from one to the other. When I have a lot of molecules in one area, they tend to move to the area where we don't have a lot of molecules. This is known as diffusion, going from high concentration to low concentration. So a real quick review then: going from a solid to a liquid is called melting. Liquid to a gas is evaporation. If I want to go from a gas back to a liquid, we call that condensation, and from a liquid back to a solid, we call that freezing. Notice here that the molecules are moving faster and faster and faster as we go from solid to liquid to gas. We're adding heat in order to go from solid to liquid to gas, and we must remove heat if we're going to go from gas back to solid. By the way, do any of you know what it's called to go from a gas directly to a solid? Didn't think so. This is known as deposition. What about going from a solid directly to a gas? Anyone? Didn't think so. This is called sublimation. Just some fun terms to know. We mentioned before that liquid water turning into a gas, what we call evaporation. This is a process we call boiling. Boiling and evaporation are kind of the same thing, except that boiling happens underneath the water's surface. So these bubbles you see in this flask are actual water molecules turning from liquid to gas. Here's a new term for you. This is called latent heat. Heat added or taken away from a substance without a change in temperature. How can heat be added or taken away without there being a change in temperature? Check your neighbor on this one. Well, you don't have a neighbor, so okay, we'll move ahead. Let's look at it this way. How is it possible to add energy to a ball without making the ball go faster? That's right, we're going to increase the ball's potential energy by lifting it over your head. Take a look. The ball has a much lower potential energy here than it does here. So we'll increase the water's potential energy by pulling water molecules apart from one another, and this is what happens when water changes phase. So we're pulling these molecules further apart, pulling these molecules further apart as we go from one phase to another phase. Interesting to note that evaporation is actually a cooling process. If we look at these water molecules, these high energy water molecules that are liquid state, they leave the liquid state as they get close to the surface, and now they're in the air. So I have had high energy molecules leaving the liquid, therefore the liquid now is cooler. These high energy liquid molecules go into the air, and the air is cool because these slower moving gaseous particles have now gone into the air. So overall the air is cooler. Why do you sweat? Or why do dogs pant and pigs roll in the mud? You sweat once again so that you can have water on the surface of your skin. It evaporates and cools your body. Same thing with dogs. Water is being passed from their tongue, liquid water, to a gaseous state, and now they're cooler. The water, liquid water on their tongue, evaporates and moves to the air, taking energy with them. Okay, so what we've discussed so far have been physical changes. So a change in the physical property of a substance. A physical property just describes the look or feel of a substance. So going from solid to liquid to gas would be a change in that physical property. The chemical property describes the tendency of a substance to undergo changes. So for example here, it's a chemical property of iron to transform into rust. And the physical change, once again here, going from solid to liquid to gas. Chemical change, transformation of one or more substance into other things completely. So during a chemical change then, the substance breaks bonds and we form new bonds. We form a completely new substance. Here we have oxygen and methane. They recombine. These atoms break apart, they recombine to form water, and carbon dioxide. So new substances are being formed through this chemical change. New compounds are formed. Here's a macroscopic view of that methane and oxygen combination.